So, ma'am, my screen is visible or not?
Yeah, it's visible.
Okay. So for importing the file format should be in IGS format. That will be better. So here, what I'm doing is again, I'm just opening designer modeler geometry. Don't go for space climb and discovery. It will be little difficult. If you have any experience, means you can try, or else better go with designer modeler, because almost all options are similar to some modeling softwares. So here, if I want to import any geometry, means file, click file, import external geometry file. Here, if you want to import anything, means you can straight away can import. See, suppose I'm want to import this submarine, one file is there, IGS file. I want to import, means we can open that, click generate, it will be imported. So now you can see here, this is your file. IGS, your file will be like this. Whatever you imported. Suppose your file you want to import any wing, means also the wing, whatever you are importing, you can see that one in the graphics interface. So after importing, you can see one part body solid. Sometimes some bodies, there will be like two or three extra here you can see the submarine is a single body. So when you are doing that analysis, CFD analysis over a body, means easily you can do, and there won't be any error during meshing. And for boolean also, so initially in 2D analysis itself, we have seen, we drawn one control volume, inside we have the airfoil shape. We did boolean for showing that the difference between the airfoil and the control volume, and also to see this the region where the flow need to be, or the analysis to be done. Okay, so here also similar pattern is similar, only thing this will be a 3D body. So for that, if suppose say here, sometimes in this region, part bodies and all, there will be like certain surfaces. In that case, it will not work out. We should close, or we should join, or we need to clean the surface properly. So if there is a single body, means easily we can do the analysis, or else based upon our design criteria, some error we have kept, that to be that means the surface to be, or the body should be cleaned, some whatever errors that to be rectified. Then if you are taking, easily you can do the analysis. See, for this part I can easily do. I'll show. So you can I will draw one control volume. You can go for any control volume. If you want to have a rectangular control volume, means that also can be done. Here we can do rectangular control volume, or else circular, means also we can go for that. So rectangular control volume symbol. Now I am doing just one normally to show you how the control volume look like. But as I said, if you want to do perfectly, means either you refer some paper, or else at least go with the standard dimensions for the control volume. That means from inlet to the body, it should be like 5 to 10 percentage the total length of the body, that you have to uh, we should consider that. Even the upper side and lower side similar way, back side 10 to 20 times the total length of the body. So now I made the one rectangular I made. Now I want to extrude that. So both sides I am extruding. And for this one is a smaller body, so this much is enough. No need to go for some bigger control volume and all. Actually, this is a submarine. We know submarines. We should. They will do either analysis inside some tunnel or in some water bodies only. So we can go with the normal control volumes. Sizes, now I am not giving the size, but when you are doing for some specific project, give the sizing for that one. I will show you what to be the sizings and all. Accordingly you fix it. So now I gave generator. So now you can see one control volume. So for this control volume, now we can see the solid body 1, solid body 2. If I'm selecting the solid body 2, we can see the control volume is getting selected. Well, if you want to hide this, you can see here, hide. I'm hiding this body, so you can see the inner control volume, and the tick mark is also like it is hidden. Now I'm giving show body, so that again the control volume is visible. So now here our criteria is to do only the external flow analysis. So for doing the external flow analysis, we should do boolean, so that we can see the surface, or that means the shape of the body which we need to do the analysis. So here I'm giving subtract, and the target body is the outer one, and the tool body is the inner one. So now if you give generator, automatically you can see inside we will be having only one body with the submarine shape. Okay, with the submarine shape. So flow will start from here, and it will move over the submarine shape, and it will leave the through the outlet. So this will be the external flow analysis for a 3D objects. So now our geometry is finished. So now next part is to like do the meshing. So anyone have any doubt regarding this? Because again, if I am going to meshing means here, if you have any doubt means I cannot come back so easily. It will take some time. Okay, fine.
I guess they don't have it.
Hello, ma'am.
Yeah, I guess they don't have it.
Okay, okay, ma'am. So I will continue in that next part. So again, meshing. So in meshing, just double click and open that. So for a project or doing some research means, first and foremost criteria is to check the grid independent study, or we will say grid independent study, or grid sensitivity study, or machine dependent study, like that we will say. So for that purpose, we should check with different mesh size, and that means element size or different meshes, and we will check whether the results are relevant, whether it is we are getting the same results. So depend upon your system configuration, this mesh we can do the analysis. So first and foremost part is to change the physics preference to CFD. So after changing that, you can see here the element size is 713 mm. So if I am giving 1 second. Sorry. So we can see here element size 713.99 mm. So that here inside this body, all elements will be meshed based upon, or this control volume will be meshed, or the grids will be formed based upon this element size. And near to the surface, to connect all the meshes all the nodes over this body, it will give somewhat fine mesh near to the surface. So like that it will form. So now our duty here for 3D object, it is very simple. We have two, three options only for doing a mesh. So first one is to give insert. We can either go with automatic method. So automatically it will give generate a mesh. Like that also we can go for, or else we should do sizing. So there are two, three options are there. Now I'm just showing one regular type because when we go for some research projects and all, what they will do, they will not mesh the body with the whole control volume. They will not mesh finely. They will take one small control volume. That control volume inside the whole control volume. See, this is the outer volume, control volume, and inside that we will make one more small control volume, and in that region alone we will give fine mesh. Here, no need to do that. We can go with straight away this for, since this is a generalized case. No need to do that one. So first of all, to do this sizing, we should hide this face, then the other face also. So once the faces are getting hidden, you can select the only the body. So the geometry is getting selected. Now we can see the element size, default element size is 713.99 mm. And here, this total length of the body is 1.6 meter. So can anyone tell how I can mesh this, what element size I can give for this body? And you can see here the defracture size is, feature size is 3.5699. And what do you mean by this D feature size? And what mesh size we can give for this body? Any idea? Anyone? Okay. So I will tell, but this is the most important thing. Many people don't know. See, I have taken classes for students, and for in maybe for your class also, like you have attended some CFD classes and all. They will tell, do mesh with give element size of 10 mm, 20 mm, 30 mm, 50 mm, but they will not tell why we are giving that 10 mm, 20 mm, 30 mm. And students, what they will do after um, maybe you will finish your lab, and when you are going for exam, they will do everything, whatever object given, they will do with that 10 mm only. And everyone will think, some cases they will go for like 0.01, 0.02, 0.1, like that they will do. What is the reason behind that? Really we need to do that, or we should think whether it is appropriate for this body or not? Any idea? Anyone? Okay, fine. So whenever you are doing your meshing, we should think in such a way that our element size should not go beyond this D feature size, first of all. And the default size will be the default element sizes of the outer control volume. So now I am doing meshing for this submarine body or whatever body. So the body size is like 1600 mm. That means 1.6 meter. So if I am dividing this or meshing this body with 713 mm means how many nodes will be created? Two nodes, maybe two, three nodes here and there, because it is a three-dimensional body. Here are there over the surface some nodes will be created. Okay, so our first criteria is to do one coarse mesh and check whether the mesh what mesh we are getting. So that should be less than this default size. So default size is 713.99 mm. So we can go with 100 or 200. Now I am giving 100. And you can check here the D feature size is 3.5699 and the element size is more than that only. So no problem. Okay. Now either you can go with again automatic method or else general. Here also, if you want to again reduce the element size, you can go with like 300 mm. So outer control volume will be meshed in that size. Then again quality, give the smoothing to high. Inflation, now we cannot give inflation, still we need to check first. Then if you want to study the boundary layer of the particular body means, then we can go for inflation, otherwise it is not required. Now give generate mesh. First check whether how this meshing is happening. See, there are some bad boundary meshes. I will show you, because outer body how it is behaving, inside how it is. So if I am giving 100, our mesh is formed in this way. Okay, if I am giving 100, the mesh will be formed in this way. But here some things we need to change, because outer is like 300, inside is 100. There will be lot of problems will happen. So again we need to change the meshes, then only it will work. So if I am giving this outer element size to 100 and inside face meshing, and one more thing we can add, that is element sizing. So element size, edge sizing we can give. In that also element size is there. We can go for like um, 5 mm if I am giving means. Here face mesh also like 10 mm on it. We will give for 50 mm, because sometimes it will take too much time, but it will take time. And one more thing, you can find some bodies, if this meshing is not happening and some more errors are coming, means you can straight away consider that there are some we need to clean the body first, then only it will mesh. Because then either you can go with the automatic mesh initially, and you can check what are all the problems which is occurring, and after that you can finalize, okay, this regions and all need to be rectified before or cleaned before bringing to mesh. And depend upon the configuration of the computer only it will work. If you are having using student version, means you cannot go for some high end meshes and all. uh, if you are using some at least i5 processor, means you can go up to 10 power maximum up to 10 power 6 mesh, the element size order. That too is difficult, somewhat. That too 4 into or 5 into 10 raised to 6 we can go for. More than that it will not work. Even if it is meshing also, after meshing analysis will not be done. So accordingly we need to do our meshing. So you can see here, since it is taking much time, I'm just doing this, showing the old one, which I did previously for initial analysis. So you can see the how the mesh is formed. So this control volume is different again, because we are I'm doing this analysis for one tunnel. Inside a tunnel, if this it's a big tunnel, so inside that if submarine is moving, means how the analysis, uh, how it will perform, like that only is a thing. So for that, the mesh will be in this, like it should be like this. You can see here, the shape should not change. If the mesh is not proper, the shape will be changed. Okay, so this is how we need to do our meshing. But here again it is a basic mesh, so I did with only with the face sizing. And outside I have given 100 mm, because again it will take time, so I did only for the initial case. If you want to increase further, and you can see the element size order, how much is the element size order. The elements are 7 lakhs 80,000 867 elements, and the notes are like 1 lakh 46,620 notes for this control volume. So if I am increasing the or this element size, if I am giving 10 here or 50 here, this will be meshed with I will get 3 lakh notes. Minimum 3 lakhs I will get. Here elements around 10 lakhs I can go for. So depends upon the thing. It will depend upon the element size. We will get the elements and nodes. So for this, see this the inlet region. You can see here, the red color region is the inlet, and opposite side will be the outlet, and this is the wall and torpedo. This one is a torpedo. So the after doing the meshing, we should give the naming name selection. So once that is also done, we can straight away uh, we should give just generate, and after that you can close the geometry, sorry, meshing. So here it is finished. You can see here the elements which is formed, and whatever the nodes and all we got is see uh, it is of very high element size. I don't think so it will work here, because you can see here how much elements and how much nodes is getting generated. This only I will show why it will work, why it will not work and all. So once this is finished, we should give the naming. I need to check. Hmm. Okay, so we got the elements mesh. We got. If you want to do grid independent study, only thing you have to change is here only. This elements, this face sizing, edge sizing, and this mesh. Here also element size. If you are changing, automatically this total thing will be changed. Now we have given somewhat a higher only, but still this much. We'll check. Then next thing is to do the naming, name selection. So select the face. Here it is create named selection. I can give inlet, and similar way other thing, create named selection outlet. Then again some faces we have hidden. Hide that faces. So show hidden faces 1, 2, 3, 4. This 4 faces you can give that as 1. Then final is the surface of the torpedo. So again I'm just hiding this face. Hide face inside also on face I'm hiding. Then I'm selecting this face, this torpedo. Right click, create named selection, torpedo or submarine, whatever you can put. Okay, so that is also done. So once that is done, you can check your namings are finished. Generate, close. Now mesh is finished. You can go straight away, go to Fluent. Then update. Everyone, did you understand up to this much? You have to explain. See, one message is in the methodology of the research paper under geometry editing. So no need to give anything about geometry editing, just the overall process. Generally what you did, what is the dimensions or something relevant to the geometry alone, you just speak. No need to show do that means explain anything about the editing or cleaning process and all. Okay, that is not required here. Again for fluent, so fluent same thing, double precision. Can start that one. வெயிட் வரேன். Problem with this is it will take time because as I told earlier itself, the element and node size is too heavy. I think so. It will computer can bear that. We need to reduce only. But that's why I told na when you are doing some analysis over that means 3D analysis, we should be very careful, like not to only the region which is closer to the uh, boundary alone, we need to give fine mesh. Other regions, we should not go with fine meshes. Still in papers and all journal articles, they will ask, for that case, we should go with some high end computers only for doing the analysis, either like but generally we have some strategy. That strategy I will tell little bit, near to the region which is a region of interest, or region of focus. That region alone we need to give fine mesh. That is a strategy many will follow to do some high quality, or to get some high quality results. So it will take some time. Better I will open the uh, other one and I'll show you. So what kind of results we will get, that I will show. So the CFD parts already, I think fluent parts and all, you are very clear, I think so. So I think no need to show that one. So this one alone I will show. Because other parts it will take some time.
Events, you can unmute and you can speak.
So I could not able to hear you. Or you put your message in chat box, I will reply.
Jenny, just give them a brief idea about mesh independent study, how it is important for
Okay.
research data. Yeah, yeah. Just give an overview about that.
Okay. So for mesh independent study, what you have to do means first start with one course mesh. That means if I am giving, I told you initially I gave one value like 100 mm, and our default size is like 700 mm, but I gave 100 mm or 300 mm initially. So for 300 mm, you will get one. That means with one normal element sizes, we will have one mesh, and we will get one nodes and element size. Okay. So if that element size is like a 10 power 3 in the order of 10 power 4, and that means nodes are 10 power 4, and elements are 1 is to 10 power 5. That means 1 lakh or 2 lakh. Just assume 2 lakh elements. So your mesh is of consist of 2 lakh elements. So for 2 lakh elements, because we are doing analysis for we will get results in the form like CL and CD, right? So for 2 lakh element size elements, your CL value of 0.445 you are getting for a particular angle of attack. Okay, let's say the angle of attack is 3 degree for a particular wing or fuselage or whatever. Okay, and you got one value for that element size of 2 lakh. Now if you want to do a grid independent study means we should reduce the element size first. That means 300 in place of 300 you have to give 200 or 100, like that, in the order of either we what we will do means we will take one results with one element size, then divided by 2, then divided by 4, then divided by 8, like that we will give element size in that order. While giving element sizes in that order, you will get your total elements, cumulative elements for your mesh, in the order of 10 power 4, 10 power 5, 10 or in 10 power 5 only, 2 into 10 raised to 5. That means 2 lakh, 3 lakh, 4 lakh, 5 lakh. We will get some different element sizes. For each element size, you have to check the CL value, CD value, whatever results you are taking. Okay. Suppose you are doing for nozzle means there either if you are calculating thrust means thrust you have to check, or else some other factor means that factor you have to check. For a three-dimensional external flow analysis over a wing means then obviously we can go and check with the CL, or in some cases they will check with some boundary layer also. So that is again different. If So initially we will go with this only CL and CD. So for 1 lakh elements, you are getting 0.424 means for 2 lakh elements your CL value will reduce, or sometimes it may increase. So we should go with 5 or 6 or 4, minimum 4 element orders or element sizes. And that element size is like it should the elements total cumulative elements should increase. That means first element size what you did, we got one elements of 1 lakh. After reducing to that means dividing that element size by 8, we should get elements, total elements, cumulative elements in the order of 10 power 6 or 10 power 5. So for that case, we will get the CL value. You should check the CL value. There will be like small change in CL value. Like we will gradually we will get some decreased or increased CL value. And in grid independent study, we will find for two elements, two or three different elements, we will get almost same CL value or CD value. So for further analysis, we can fix that elements. That is grid independent study. That means when we are increasing, even after increasing the sizes, the values which the output or results which we are getting, there is no change, or the change is so meager so that no need to worry about that. that will be negligible. In that case, we can do our work. We can start doing our analysis in that fashion only. Okay, that is called grid independent study or mesh independent study. So someone asked one more question. The attachment you sent yesterday has many files in it. How are we going to import all of them together? So actually, you are not going to import all of them together. Any one. See, I don't know what the files in that. I think it is some.
Yeah,
Uh,
actually, that was entire aircraft files were there
yes.
separately, like
Yes.
fuselage, wing, and horizontal tail. They are having separate files
Mm-hmm.
for each, like IGS file is there. So
Mm.
that's what they are asking actually.
Okay.
So how to
We
import
cannot
it?
import all files. Actually, if you want to import all files, means again, I said that if there is any small error, means we need to clean the body. It will not getting imported. Boolean will not happen. If Boolean is not happening, then again we cannot go with further analysis. So we should correct each and every body. Even there is a minor error, some connectivity error also, sometimes it will not work out. Or else we should make us a single body and we can import. That is also possible. In like that only we can go inside. If you want to do analysis over a fuselage, you can go with fuselage alone. But if you want to do with the whole aircraft, means again I have to make that body in a single file, or else in Boolean we need to delete or see. I did subtract in Boolean in the designer modeler. Say similar fashion you have to do. Then it will work out.
Yeah. So they can their main task was to work on the fuselage only. So with a different machine sizing, so we are giving the limit. So they has to use that only. Only the
Yes.
shape of the fuselage is can they can import. Just like
That is
example
more
you
than
have
enough.
shown.
That is more than enough. Only thing, this torpedo analysis is similar to that only. So
Yeah.
import that file, make control volume. Even my suggestion is like, since you are working for some project, better go with a standard control volume. That will be better. That values and all. Again, no need to work on that again. So the dimensions, everything, go with the standard one, standard dimensions, so that easily you can proceed your analysis. Okay.
One more issue they are facing that when they're importing the file, how to
Mm.
identify or check that about the dimension. So because according
Dimensions, it is easy, ma'am. There in geometry only, tools one, designer modeler tools one option is there. Okay. Uh, One toolbar is there in top. File, create, then tools, like that concept tools, like one option in one toolbar is there. There, click on tools. There one option we will be having analyze. In that option, click that option. There, you can see measure option is there. You can measure the dimensions. Actually, the zip file has an assembly file with the 4 parts. Can we combine all into one part, and how to make the domain for 4 parts? No. See, if the assembly file is there, means inside when you are importing, it will be like 3 4 bodies are there, but file is single only. Okay. So, and the control volume is control volume, whatever the body, we need to make one single control volume. No need of making multiple control volumes. One single control volume is more than enough. Okay.
yes, so when you're assembling the product is one. So in the over the product only you are going to make the control volume, right?
Yes. Yes, ma'am.
Any other further question you have?
See, up to this much, once meshing is ready, you can go with other. So better, what we will do, you just import the model, only the fuselage first you import, then make a control volume. with the proper dimensions, with referring some papers, that will be good, standard one. So and after that, go with meshing. So once meshing is done, then we can go with the remaining things, because I don't know whether that body is everything, it is proper or not. That we can see only through that meshing alone. So we need to do the meshing, and we can see how it is working. Okay. Once meshing is done, then next part I will explain what to be done, what values to be given and all. So any other doubt?
Yes, first you do for the fuselage. Okay. First you try for the fuselage. And first we have given you the task about the meshing only. In that meshing, what is the value that you're getting? First you extract that thing. Okay.
I think so they will do the same thing, ma'am. Once that is done, we can go with the other part.
Yes, yes. Yes,
Uh,
then we can go with the overall and assembling and they find. Then they can also find that with and without how the difference they're getting. Right?
yes, yes, ma'am. So any other doubt? If you have any doubt, means you can ask, or else we can wind up here. Yes. See, I could not able to hear you. Once again, repeat, or just contact region. What about the error in the contact region? See, contact regions for this things, contact region is not required. If you want to give contact region, means you have to clearly specify. Okay, which is the, what is this region? What is that region? That some option is there that you have to do. Otherwise, don't go with the contact region. That is not required for doing external analysis and all. Contact region and all not required. Okay. Or if you have any doubt, you can send me the screenshots. I will show you. I will explain what to be done for that. Better, no need to do that parts and all. Usage file is giving an error when being important. No, it will not give error. I think I tried once. It will not. It will not give any errors. You try once again.
Already we have tested this file, right?
Yes, we tested this
Yeah.
file. So
Yeah.
no error in that. Maybe some you have to check. You just check. Save that file as IGS and import it.
It is already an IGS file. I
Yes,
just
then no problem. You can straight away import. Definitely it will open. Any other doubt? And what kind of this answers file you are using, that also matters. Sometimes some cases even see license will be like cloud license will be there. That time sometimes some error will happen, so better to close that. Some error is happening means close the system, try after some time, automatically it will work. Okay. And student version, many errors will come. So again, we only need to rectify that, no other way. Sometime later you can try again. Sometimes it will work, sometimes it will not work. That is for student versions.
Jenny, can you share any website that from where they can download the crack version and they can work
Yes,
with
I
what?
can show you, ma'am. So I think my screen is visible. See,
Yeah, yeah,
filecr.com, one website is there. Filecr.com. Okay.
yeah.
Here you can search ancestor. If I'm searching ancestor, every all files you will get. Ancestor, see, total 2024. That is itself. It is there. Almost everything will be there. Okay. Only fluent means fluent is there. Answers, additive manufacturing, all add-ons also it is there. Better you can download this only.
I hope they had this doubt as well. So I hope
Oh,
that we have cleared that from where they can download.
yes.
I think here we can wind up the session. If they have any further doubts, they can just mail.
Okay, ma'am.
Yeah. First, the thing is that they has to practice. They have to give the output of what they're getting.
I
If
will
they're
share
facing
some
any,
normal YouTube videos, how
uh,
to do normal analysis or 3D analysis. Accordingly, they can practice first.
yes, yes.
Once that is done, we can go with the other things, because for see, I will show one paper, how they. You asked grid dependent study. You can see from here. See, number of mesh A, mesh B, mesh C, D, E, and here they have three parameters: skewness, average, one value y plus, then CD. CD is nothing but a coefficient of drag only. Since capital means for a 3D object, we should give this one only capital. Otherwise, a small c suffix small d they will use. So here only you can see for 5 lakh, what is the value CD value we got. But for 8 lakh, how much is the value we are getting? So this is how the things will change. Okay, and for this y plus value also we are changing. So for different y plus value, we are getting different mesh size mesh elements, node elements, and for that we are getting different values of CLCD. So now you can go with this two mesh. Almost we are getting similar, zero point 0.2 range only we are getting. Still we can go further also, but what they will do, they will go with this one, since because of some see here and a lot of too much change. Okay, like this they will take some values, and the skewness average also it is getting maintained here. Here it is like it is too much differences there, and the results also I'll show. See what kind of results they are taking. This and all, we for a paper, if you want to do some analysis like this, we need to take results. Can show. So hypothesis, how the hypotheses are found, everything they addressed very clearly. Okay. So like this, we should do some work. Okay.
Can you share this paper link in the chat
Yes,
box?
I will
So
send, ma'am. I'll send. Okay, ma'am. So if they are having any difficulty, means I will. Um, you can share that screenshots. I can help you in that now.
yeah, yeah. Okay,
Okay. Okay, ma'am.
okay.
Okay.
Okay,
Thank you.
thank you so much.
Ah.
Thank you, everyone. Events, this how to import already in the beginning of the session. It has been started. I think you have joined late, so you can check out the link in the which is available in the YouTube. So you can refer that. All right. So already, sir have shown that how to import the file. So please do refer that. Okay, how to import the file. Okay. Thank you, everyone. Good night.